Hello, nice to meet you. It's a big honor for me to present our research at Intelligent System Conference. My name is Hyun Jo. I am a PhD in Management Engineering. The name of the company I belong to is RealSecu, and we pursue information security. We are providing security solutions to protect systems. Today's topic is a recommendation system based on big data, separation of preference and similarity. Web users manage online resources using tags. Instagram users register keywords, their feelings, and words they wanted to say with text while uploading their posts. Twitter users express their opinions by tagging when they retweet a tweet. If a user uses a specific tag relatively often, then user may be interested in resources related to that tag. Users may have different interests over time. Examples are here. If Netflix dramas in South Korea become a box office, tag may be squid, like Squid Game. That is in an online environment created by tagging, one can infer the tendencies of users based on the frequency and viewpoint of the tag. Users' interests change over time. For example, two men wanted to know the female heart because they wanted to be in a relationship. They searched for information related to women's minds to obtain relevant information and bookmarked appropriate sites. Those who studied love through writing succeeded in love and got married. 10 years later, their interests shifted to education and school of their children. They searched for sites related to good schools and bookmarked them. It is shown in figure. Time is important information in identifying user tendencies. This study calculates user ratings with time information. What is special is that the cardinal information is reflected in consideration of the user's total usage time. Cardinal information can capture users' thoughts more accurately than ordinal numbers. Similarity calculation applies cosine distance calculation as formula shown in this slide. This study presents a new idea. It is to allow the preference matrix and the similarity matrix to be independently reflected when calculating the final prediction value. A specific individual's preference may be more accurate when tag information is reflected, whereas similarity measurement between users may be more accurate when time information is reflected. To empirically test this idea, this study implements a total of 4 recommended methodologies. This study obtained real big data sets from Margarin. Margarin is a Korean social bookmarking site. The Margarin dataset was gathered by crawling the site using Python. Data size is described in the slide. In the performance evaluation of recommender systems, this study employed 3 matrices: precision, recall, and operation. This figure shows the precision values of 4 combinations of compared to the benchmark among various neighborhood sizes. W time, S time, which means time-based rating and time-based similarity, show the highest performance among the proposed methods. On average, W time, S time was higher than the benchmark by about 3.3 points. Regarding to recall score, W time, S time outperforms benchmark overall. On average, W time S time was larger than the benchmark by about 11.8%. W time S time was dominantly superior in all neighborhood sizes in regards to F ratio. The second best combination was W time S tag. On average, W time S time was greater than the benchmark by 5.1%. The conclusions are as follows. First, this research independently reflects the process of calculating user preference and computing similarity. Second, this study collected and processed a huge amount of information on the behavior of web users. The generality of research results was enhanced through big data analysis. Third, this work contributes to the literature in that it considers tag frequency. This method reflected the scale of information more closely than the existing binary preference matrix. Finally, this paper identified users' tendencies more accurately than the existing ordinal scales by considering the tagging time as a cardinal scale. Thank you for listening.